Okay, so this is a key to worksheet 2 for topic 18, part A. And in number 1, it says you want to graph h of x, which is the absolute value of x minus 5. And you're going to do this using transformations, because this is what topic 18 is about. Topic 18 is about transformations. So then the graph of the parent function f of x is shown below. So my parent function is the absolute value of x. All right, so there's your parent function. There's the graph of the parent function. And you want to describe the transformation that is needed. So what do I need to do to f of x to get h of x? All right. I kind of started out for you. It says to obtain the graph of h of x. So obtain this graph, you would shift the graph of f of x. You would shift the graph of f of x blank 5 units. All right. So you see where that 5 units is coming from? This 5 right here. Now remember, one of the things you learned was that if the number is on the inside of the parent function, so my parent function is um, the absolute value of x, and so notice I'm going on the inside of the parent function, and I'm subtracting 5. So if the number's on the inside, then that's a horizontal transformation. So this is going to be a horizontal transformation. All right, horizontal transformation. And when you think horizontal transformation, think the opposite of what you see. So many students, when they see x minus 5, they think negative 5. They think negative 5, and they want to shift this horizontally to the left 5 because negative 5. That's not the case. That is not the case. You have to remember that for horizontal transformation, it has to look like this: x minus, and then this number here, that goes inside the circle, that is your horizontal transformation. And so notice x minus 5, x minus 5. So 5, positive 5 is your horizontal transformation. So think the opposite of what you see so you don't get confused. It is difficult to remember. The horizontal transformation is more difficult to remember. So then what I'm going to do here is I'm going to take my parent function, my basic function, and I'm going to shift it to the right 5 units. So shift it to the right 5 units because 5 is positive. So we would shift the graph of f of x horizontally to the right 5 units. Okay? All right, so every point on that graph you shift to the right 5 units. So always start with the vertex of the absolute value. 1, 2, 3, 4, 5. Okay, at that point. Look at this one. 1, 1, 1, 2, 3, 4, 5. Let's use this point. 1, 2, 3, 4, 5. Okay, let's go in that other ray now. 5 units to the right. 1, 2, 3, 4, 5. And then let's do this one. 1, 2, 3, 4, 5. And that's enough. So we can just graph now. So this right here, this is the graph of this right here. That's the graph of h of x. So this is h of x, which equals the absolute value of x minus 5. Okay? All right. And listen, you can always check your work. It's always, see, if you're not sure what you have is correct, do this. Always verify. All right, so you see you have h of x equal x minus 5, right? You think that's the graph. All right, well, let's look at this point. So this point here is 5, 0. You agree? You agree that's 5, 0. All right. Well, substitute that into your function. Remember, h of x means the same thing as y. So substitute that into your function and see if that makes this a true statement. So y is 0. You agree? Y is 0. So is 0 equal to the absolute value of x? X is 5 minus 5. What's 5 minus 5? Well, 5 minus 5 is 0. Absolute value is 0, still 0, and that is a true statement. Let's do one more just to verify. Let's use this point here. Do y'all agree that this point here is 6, 1? 6, 1? All right. So let's substitute 6 for x and then 1 for y. So we have y equal absolute value of x minus 5. Let's see if that's true. So 1 equals the absolute value of 5, 6 minus 5. 6 minus 5 is 1. The absolute value of 1 equals 1, and that's a true statement. So always check. Do what I just did. It's easy at the end to double check your work here. So you just take, whenever you do your transformation, take a couple of those points, plug it back into your function and see if it works. Okay? All right. So that is number 1. All right, let's look at number 2 now. So number 2, you have, so it says graph, so you want to graph this function right here, g of x equal the absolute value of x plus 2 minus 6, and you're told the parent function is the absolute value of x. So there are 2 transformations that must occur to the parent function, which sometimes are called the basic function, to obtain the graph of g of x. In the coordinate plane below, you're going to draw 3 graphs. The parent function will be one of them, and the 2 transformations will be the other. So indicate the parent function with f of x and the final transformation with g of x, because that's what you wanted to graph. Okay, and it did say this. It said see the sample to understand what I want. So I'm hoping you did this. I'm hoping you looked at that sample graph to understand what I wanted. Okay, so the first thing you got to do is, remember there are 3 graphs you got to draw. So the first one is your parent function. So your parent function. So remember how we get the parent function, how we get the graph of the parent function. So we're going to do a t-table. And so if x is 0, the absolute value of 0 is 0. So I get the point 0, 0 right here. If x is 1, I get the absolute value of 1, which is 1. So I get the point 1, 1. If x is 2, I get the absolute value of 2, which is 2. So I get the point 2, 2. So this side looks like this. This ray looks like that. Again, I didn't draw it very well, but I'm not going to erase because I use a pen. Let's go on the other side. So if x is negative 1, the absolute value of negative 1 is a positive 1. So I get the coordinate negative 1, the point negative 1, 1. And then if x is negative 2, I get the absolute value of negative 2, which is positive 2. So if I plot the point negative 2, 2, I get this. And so this side looks like this. Okay? All right, so that's your parent function, and that's what you saw in number 1, by the way. See your parent function? So that's what you saw. All right, so I drew the parent function. All right, then remember our process. There are 2 transformations. There are 2 transformations that's occurring here. Remember this, that if the numbers on the inside of the parent function, then that's a horizontal transformation. So this right here is horizontal transformation. We just put HT for right now. Horizontal transformation. And the number on the outside, that's that vertical transformation. So this is a vertical transformation. Okay? All right, now remember our discussion earlier. Right here. So many students with the horizontal transformation get confused. They see a negative 5 and they want to shift it to the left 5 units. But remember, you always got to do the opposite of what you see. So the point is this, though. The point is see where I have g of x. Let me write it right here. G of x equal the absolute value of x plus 2. Let's look at that for right now. Remember, always do the horizontal transformation first. Do the vertical transformation last. Vertical transformation last. Do that last. Okay? All right, so I want you to notice that in the previous problem we said that whenever you have a horizontal transformation, you want to rewrite as x minus and then put a circle. So this is going to be g of x is going to equal the absolute value of x minus, and then keep in mind that x subtract a negative 2 means x plus 2, right? So x subtract a negative 2 means x plus 2. So negative 2 will be my horizontal transformation, my horizontal translation. Okay. So what that means then is that I'm going to shift the function f of x, my parent function, to the left 2 units. That's what that means. So I'm going to shift it to the left 2 units. So let's go ahead and do that. So every point on that graph of my parent function, I'm going to shift to the left 2 units. That's what that says. So you're going to shift to the left 2 units. All right, so that's the first one you're going to do, your first transformation. So let's start with the vertex. So I go 1, 2, 1, 2, 1, 2, 1, 2, and then 1, 2. And so this right here, just to let you know, this is y equal the absolute value of x plus 2. That's what that is. Okay. Now the last thing I'm going to do, so there's my parent function, there's my first transformation, and then my next one is going to be where, now the vertical transformation, the vertical translation, that's always the easiest to do. You're subtracting 6, that means you go down 6. All right, so the second thing you're going to do is then you're going to now shift it down 2 units. I'm sorry, 6 units. 6 units. Shift it down 6 units. So I'm going to use a red pencil. And so the vertex, I'm going to shift down 6 units. 1, 2, 3, 4, 5, 6. Then over here, 1, 2, 3, 4, 5, 6. Let's do one more point on this side. See, the absolute value is made up of 2 rays, so pick enough points on each ray to get your graph. 1, 2, 3, 4, 5, 6. So here's the first one, the first ray, and then do the same thing here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And now this right here, this is g of x, which is the absolute value of x plus 2 minus 6. All right, so that's what that is. Now remember what I said. Always check before you move on. See if that's a true statement. See if that's true. So in other words, we're going to do just like we did this one. So now I have g of x, which we said is x, the absolute value of x plus 2 minus 6, right? So let's see. I'm going to pick some points here. I'm going to see if it works. So let's look at this point here, right here. So that's the point -2, -6, right? -2, -6. Y'all agree? So in place of x, I'm going to substitute -2. In place of y, I'm going to substitute -6. Okay, so here's what I have. Remember, that means the same thing as y here. So y equals the absolute value of x plus 2 minus 6. So let's check. Remember, we're checking -2, -6. Check -2, -6. See if it works. So y is -6, so -6 equal, I want to see if that's going to equal this side. So that's the absolute value of -2. Remember, x is -2 plus 2 minus 6. Well, -2 plus 2 is 0, and the absolute value of 0 is 0, right? And 0 subtract 6 is -6, which is what this is. So it looks good. Let's do one more. Let's check one more. Let's check this one right here. So this one right here is -4, -4, -4, -4. Let's check that one, see if it works. So let's check -4, -4. So in place of y, I'm going to substitute -4. In place of x, I'll substitute -4. So I get -4 equal, that's what I see, the absolute value of -4 plus 2, subtract 6, right? The -4 plus 2 is a -2. I want you to notice something. The absolute value of -2 is a positive 2. And 2 subtract 6, that's a -4, which is what I wanted. So what I have here is correct. That's a correct graph. That's my final transformation. All right? So remember what we just did. So basically, you're going to do your horizontal transformation first. So you're going to take your parent function, you shift it to the left 2 units. That's how we got this graph right here. Then you can do your vertical transformation next. So I'm subtracting 6. That means I go down 6. Okay? All right. So that was number 2. So that is the key. That is the key to topic 18, part A, worksheet 2.